Before going into anything, the first important thing to know is that with any triangle that you have, all three angles, when put together, make up 180 degrees. When working specifically with right triangle trig, the important thing to know is that when you are trying to find missing or specific sides and angles, what you will use is SOHCAHTOA. SOHCAHTOA is sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. To be more specific to this triangle, what this would mean is sine. Let's say we're going to use this angle. Sine is going to be C over B. Cosine is going to be A over B. And tangent is going to be C over A. In this triangle, A is adjacent, B is opposite, and C is the hypotenuse. And in terms of the Pythagorean theorem, which is A squared plus B squared equals C squared, the C squared is also C, the hypotenuse. So basically, the Pythagorean theorem and right triangle trig both go together. Now that you know your first three trigonometric ratios, I'm going to teach you three more. And they actually happen to all relate to the first three. The first new one, which is based off of sine, is cosecant, also known as CSC. The second one, based off of cosine, is secant. And the third one, which is based off of tangent, is cotangent. Because these are all reciprocals, it's pretty simple. Cosecant is just hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. Now, you have 6 different ratios, all relating to one right triangle. As an example, let's use this triangle and say that the sides are 5, 2, and root 29. Before we start finding any ratios, let's just remember to clarify that if this is our theta, 5 is going to be the adjacent side, 2 is going to be the opposite side, and root 29 is going to be our hypotenuse. Okay, now let's start. Cosine, which is adjacent over hypotenuse, is going to be 5 over root 29. Sine, which is opposite over hypotenuse, is going to be 2 over root 29. And tangent, which is opposite over adjacent, is going to be 2 over 5. Instead of having to use our triangle to find the other 3 ratios, because now we've learned that these 3 are reciprocals of these 3, all we have to do is flip. This means that secant is going to be root 29 over 5. Cosecant is going to be root 29 over 2. And cotangent is going to be 5 over 2. It's that simple. Even though the C and the C and the S and the S look like they should go together, that is false. Make sure that you remember cosine goes with secant, and sine goes with cosecant. That way, you won't get the reciprocals wrong. What if I gave you a triangle and the only piece of information that I told you was that secant is equal to 6/5? What would you do? Well, if secant goes with cosine, then obviously it's adjacent over hypotenuse. So it's 6/5. And then, after that, you can use a squared plus b squared equals c squared in order to find out the missing side. Now hang on a second. Does this look right? Does this triangle look like this side should be longer than this side? I don't think so. Yeah, this is wrong. Because what is secant? Secant is the reciprocal, which means that you have to flip these. Otherwise, your math will be incorrect. The first thing that you would do is you would try and see how much of that information you can put onto your triangle. If you know that secant is the reciprocal for cosine, and cosine is equal to adjacent over hypotenuse, then secant is equal to hypotenuse over adjacent. And this means that the hypotenuse is 6, and adjacent to that is 5. So, if we take the information that we know and go and plug that into our triangle, assuming that this here is theta, we know that the hypotenuse of our triangle is 6, and we know that the adjacent side is 5. Now, using only the information we have about secant, let's fill in as many of the ratios and as much of the triangle as we can. Let's start by working backwards. If these are all the reciprocals, that means the opposite of these are going to be these. Therefore, the opposite of secant, 6/5, which is cosine, is going to be 5/6. Let's see if we can fill in anything else. Let's go to sine. We know that sine is opposite over hypotenuse. Let's see if we have any of that. Do we have the opposite? No. So let's make an x for now. Do we have the hypotenuse? Yes. The hypotenuse is 6, which means that the denominator has to be 6. And when you go and do the reciprocal, which is secant, we know that right now, this is what we have. Let's do the same thing with tangent. If tangent is opposite over adjacent, and we still don't know the opposite side, let's leave that as an x. And our adjacent side is a 5. So now, when we go to do cotangent as the reciprocal and flip it, we know so far we have 5/x. Here's the question. What is x? Like I said earlier, the Pythagorean theorem plays a role in the math that we're doing. The Pythagorean theorem, which is a squared plus b squared equals c squared, is going to help us to figure out what b is. First, let's plug in what we know. A is 5, so we have 5 squared. We don't know what b is, so we'll leave it as b squared. And c is 6, so we have 6 squared. Then we can turn that into 25 plus b squared equals 36. And then we can subtract 25, and what we are left with is b squared equals 11. If b squared equals 11, and we square root both sides, b is equal to the square root of 11, which means that the opposite side of our triangle is root 11. We can also fix our ratios because we have the opposite side. Now you have your 6 trig ratios and you have all 3 side lengths for your right triangle. The right triangle trig unit has a large number of different kinds of triangles. But in this unit, there are 2 special right triangles that are an exception because they will never change. The first one is the 45-45-90 triangle, and the second triangle is the 30-60-90 triangle. Along with the fact that the angles for this triangle will absolutely never change, the rule for the sides of this triangle will also never change. The 45-45-90 triangle is always going to be x, x, and x root 2. The 30-60-90 triangle is always going to be x, x root 3, and 2x. A trick for remembering these triangles is that in the 45-45-90 triangle, because it's isosceles, that means these sides will always be the same, and therefore it's simple. They will always be x. The way to remember root 2 is that it is an isosceles with 2 identical sides. 2 identical sides and the number 2. A way to remember the 30-60-90 triangle is if you know that you have an x here, then you also have an x on the bottom of the triangle here. To remember x root 3, if you always lay the triangle out like this, these 3's, the 3 from the 30 and the 3 from the root 3, will always be next to each other. And to remember 2x, you know that 2x is the largest side because 2x is going to be the largest number in this triangle. And the hypotenuse is always the longest side. So you have the largest number on the longest side. Just like all of the other triangles, including the ones that we have previously done, these 2 special right triangles also have 6 trig functions. The nice thing about these triangles is that because the sides of them will never change, the trig functions will also never change, which means if you basically memorize the chart that I'm going to show you, you will never have to do math in order to figure out one of the functions for one of the triangles. Now, using information from what we have already previously learned, we are going to learn how to solve these kinds of right triangles. What solving means is we're going to try and figure out what all the side lengths are. And now, something that we have not covered yet is we are going to try and figure out, knowing that this is already 90 degrees, what this angle measurement is and what this angle measurement is. Let's say that you are given this side and this angle. You would be able to find out this, this, and this. Let's say I gave you this as an example of a problem and said, solve this triangle. The first thing that you would do is determine, is this a special right triangle? If not, the next step you would take is you would use SOHCAHTOA. Because we know that one of our special right triangles is the 45, 45, 90 triangle, and here we have a 45-degree angle, and here we have a 90-degree angle. That means because it has to add up to 180 degrees, we know that this is a special right triangle. Solving this triangle is actually much simpler than it may seem. Because we already know that one of these angles is 45 and this one's 90, that means that the other angle is 45 because it's our special 45, 45, 90 triangle. Then, in terms of the sides, if we know that one of the sides is 7, and both of these sides, because it's an isosceles triangle and both sides have the variable x, the other side has to be 7. And for the hypotenuse, we know that it has to be x root 2. And if we know that x is 7, all you do is replace the x over here with a 7. So the hypotenuse is 7 root 2. It's that simple. The next thing we are going to learn about is angles of elevation and depression, which has to do with one's line of sight. So let's say that the line of sight is here. If there was an object above it, and this was the angle that was going up towards it, this would be the angle of elevation. And if there was something below it, and the direction was down, this would be the angle of depression because it's depressing downwards. Let's say we had a tiny bug on the ground, and over here was a human being. Behind them is the sun, and the human being casts a shadow. If we're looking from the perspective of the little bug to where the shadow lands, and we know how tall the human being is, and we want to figure out how long the shadow is, this is an example of an angle of elevation question. If I told you that this angle of elevation was 35 degrees, and I told you that this person was 6 feet tall, using what we know already about SOHCAHTOA, you could determine how many feet long his shadow is. Because this is our angle, and we know that this is the adjacent side and this is the opposite side, we are going to be using tangent, which means when we set up the equation to try and figure out the shadow, we are going to have tangent of 35, because that's our degrees, is equal to opposite, which is 6 feet, over x. And that's what we're trying to find out, the shadow length. When you do the math in the calculator, what you will do is tangent of 35, and that's equal to 0.47. And if you know that you have 6 feet, you'll do 6 feet divided by 0.4738 and solve, and this is your answer. The shadow length is 12 feet, 0.6. Now you can change x to 12.66, and based on the angle of elevation and having the height of the person, we were able to figure out the shadow length. Now, let's review. First, we learned SOHCAHTOA. Based off of SOHCAHTOA, we learned that we have reciprocals. And for sine, we have CSC. For cosine, we have SEC. And for tangent, we have COT. And all you have to do to get those is flip. Then, when you have one of these three fractions, also meaning that you have two of the sides, you now know how to solve for the third side using a squared plus b squared equals c squared, the Pythagorean theorem. Next, we learned that we have two special triangles. We have our 45, 45, 90 triangle, and we have our 30, 60, 90 triangle. And when you know that you have one of these, you no longer need to use SOHCAHTOA, because with a little bit of memorization, meaning the chart that we learned earlier, you can know how to find any of these sides. You also know how to take your special right triangle information and your SOHCAHTOA information, and if you're given any triangle and given one angle and one side, you know how to find the other angle and the other two sides. You will determine if it's a special right triangle, and if not, you will use SOHCAHTOA, and you will be able to get your answer and completely solve this triangle. And lastly, we learned about angles of elevation and angles of depression, which are also interior angles.